and welcome to this lesson. In this lesson, we'll be learning trigonometric ratios, okay? And today we'll be learning about inverse of trigonometric ratios. We'll be learning about the inverse of trigonometric ratios. What exactly is this about? Now, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So we have inverse of trigonometric ratios, okay? And now, given the trigonometric ratios of an angle, we can obtain the angle using the inverse of the trigonometric ratio. Okay, now basically what this is you're often given an angle. So you have, let's say, 60, and you want to find the sine of 60. Okay, want to find the sine of 60, and you just go sine 60, and it gives you an answer. Okay, and sine 60 is 0.8660. If you use your calculator, you get that. Now, what we're going to learn about today is, what if you were given the trigonometric ratio and told to reverse that process and find the angle? Okay, so if I ask you what sine of what angle would give you 0.8660, and that's where trigonometric inverse is coming in. Okay, so basically trigonometric inverses they return that process, okay, or they reverse that process. And basically what you have is, if you have that sine theta equals m, okay, then theta, the angle, equals the sine inverse. Okay, that's what it's called. So we have sine inverse, cos inverse, tan inverse, and in this case we have the sine inverse of m. So if you find the sine of an angle, it gives you a result. The sine inverse of that result will give you the angle back. Okay, and sine inverse is the trigonometric inverse of sine. Cos inverse is the trigonometric inverse of cos. Tan inverse is the trigonometric inverse of tan, and so on. Okay, now find the value of theta by finding the inverse of the following trigonometric ratios. We have, if sine theta equals 0.8660, already mentioned this, and we have tan theta equals 1. All right, now if you go on your calculator, okay, and basically you look at the point where you have sine, cos, and tan, if you look right above those buttons, you would find the sine inverse, the cos inverse, and the tan inverse. And basically what you do is you hold down shift, you press down shift, and then shift would then, and when you press the sine, it will actually give you the sine inverse, okay? And when you say shift sine, it will write that as sine inverse, and then you put the digits you're looking for, and it will actually give you the value for the angle. So if you go shift sine inverse of 0.8660, it will most definitely give you 60 degrees. And if you do the same for tan, the tan inverse of 1, it will give you 45 degrees. Basically, you can find the sine inverse, cosine inverse, tan inverse of pretty much anything, okay, and it will give you the angle for that operation, basically. Okay, so now we have this triangle here. Okay, we have this triangle, very common triangle, 3, 4, and 5. Okay, Pythagorean triple, and basically we're looking to find the angle there. Okay, and to find the angle there, what we need the trigonometric ratio, and once we have the trigonometric ratio, we can find the inverse and then find the angle. So what it is we just pick any of the two, okay, and in this case I'm going to be working with sine, okay, and for sine, the sine of this angle, we have 3 divided by 5, that is the opposite divided by the hypotenuse, and then what we have is 0.6. So to find the angle, we just find the sine inverse of 0.6, and basically if you put that into your calculator, you end up with 36.87 degrees. And that's pretty much it. Trigonometric ratios, the inverse of trigonometric ratios, pretty straightforward. If you're looking to find the angle given the trigonometric ratio, you're just looking to reverse the process. Again, if you have an angle, you can find the trigonometric ratio with that angle. If you're given the trigonometric ratio and you want to find the angle, you use the inverse of the trigonometric ratio. And I have just one example, okay, and I have this triangle, and we're looking to solve for the value of theta in the right angle triangle below. And then basically what we have is we're given 6.5 and 10, and if you look closely you'd find that 6.5 is our opposite and 10 is our adjacent, so we're working with tan. Okay, so the tan of theta is O over A, and this time we're looking for theta. We're given A as 10, we're given O as 6.5, and basically what we have is we have that tan of theta equals 6.5 divided by 10. Tan of theta is 0.65. Okay, then the theta would be the tan inverse of 0.65, and theta would be that, basically, quite simply. So yeah, very simple, very short lesson, just a very simple, straightforward principle. You can go ahead now and attempt questions on the worksheet. Bye for now.